Hello, Statlings. In today's video, we're going to look at exercises 1 and 2 from the review exercises in Chapter 2 of Freedman, Pisani, and Purves. In Item 1, we look at the Federal Bureau of Investigation reports of state level and national data on crimes. First, we'll look at Item A. An investigator compares the incidence of crime in Minnesota and in Michigan. In 2001, there were 3,584 crimes in Minnesota compared to 4,082 in Michigan. He concludes that Minnesotans are more law-abiding. After all, Michigan includes the big bad city of Detroit. What do you say? Well, first, to unpack this problem, let's organize the data in the prompt. So we're given the number of crimes in Minnesota and Michigan. But is this enough data to draw a conclusion about whether the citizens are more law-abiding in one of these states? If so, we could just compare their numbers and say, well, more crimes were committed in Michigan. But what about the population size? We need to slow down and think about these numbers in their proper context. And remember, you need to answer the right question here. So the question is not where were more crimes committed. The question is, are Minnesotans more law-abiding than Michiganders? And let's think about law-abiding society as one where there are fewer crimes per person, because we need to have a good rubric for comparing these states. So we need to add into these numbers a denominator here. So for each state, we can look at the total number of crimes and then get a rate by dividing that by the total population of the state. The lesson here is that you need to compare crime rates, not just the raw number of crimes committed. In this item, we would need more information in order to decide whether or not Minnesotans or Michiganders were more law-abiding, and in fact, the populations of these states are very different. Let's take a look at the next part of this item. Part B. From the same data set, an investigator compares the incidence of crime in the US in 1991 and 2001. In 1991, there were 28,000 crimes compared to 22,000 in 2001. She concludes that the US became more law-abiding over that time period. What do you say? Well, the first thing you should be saying to yourself is, I need to start by organizing the information from the prompt. Always organize your data first. So we know that in 1991, there were 28,000 crimes, and in 2001, there were 22,000 crimes. So to compare these and look at how law-abiding people are in the US over time, we need to compare the rates, not just the raw numbers of crimes committed. We need to look at the number of crimes by the total number of people in the US population at each time point. It's always important to look at your numbers, your data, in terms of a meaningful scale. In this case, the scale is the total population, which gives us the crime rate. We have one more item to look at in this video. We'll look at item 2 here from our review exercises. In this one, the National Highway and Traffic Safety Administration analyzed thefts of new cars in 2002, as well as sales figures for that year. So this is crucial information, and you should always assume that the information given in the prompt is important to you one way or another. And here they're reminding us that there is possibly a denominator, hint, hint. Let's look at part A. There were 99 Corvettes stolen and 26 Infiniti Q45 sedans. Should you conclude that American thieves prefer American cars? Or is something missing from this equation? Let's take a look at this problem. First, we'll organize the data. We have 99 Corvettes and 26 Infinitis. Now, if it were enough to just compare the raw numbers, we would be done. But we're not done because we need to compare these numbers in terms of the rate at which the cars themselves were sold. So we can look at the number of Corvettes stolen per Corvette sold and Infinitis stolen per Infiniti sold. And that will give us our theft rate for each of these different vehicles. And the theft rate here would be the number of thefts out of the total number sold. And so that's what's missing from the equation here. And you don't need to actually do any math. I know some of you are just dying to do more arithmetic, but so much of this is about learning to think about it right and to frame it properly. Otherwise, the arithmetic doesn't make any sense anyway. So here we have the theft rate is what we would really need to know to analyze what's missing from the equation. And incidentally, it's so important in our current data-driven age, in this age of fake news, etc., to recognize when more information is needed in order to frame some data that's been thrown at you. Even if you don't know the exact number, it's so important to know that it's missing. So let's take a look at the next part of this exercise. Part B. There were 50 BMW 7 Series cars stolen compared to 146 in the 3 Series. Should you conclude that thieves prefer smaller cars, which are more economical to run and easier to park? Or is something missing from the equation? Of course, something is missing from the equation here, but let's organize our data first. We have 2 car series, the 7 and the 3, and we're told 50 cars were stolen from the 7 series and 146 were stolen from the C series. But of course, you are probably at this point saying, but how many cars of each series were sold? This is some crucial information missing from the equation here. And we would need to know the total number sold for each car in order to really know which car type thieves prefer. And incidentally, we are also given this tempting extra information in the prompt that maybe thieves prefer smaller cars that are more economical and easier to park. This is just to give you, lead you astray a little bit, to help you become a better consumer of information that's put out there. So you should filter out that part and just remember to focus on the data and thinking about how that should be expressed. And it should always be expressed by comparing rates in this type of exercise. So we have one more part to our video, and for our finale, we'll look at part C of this exercise. And part C is a little different. Let's take a look. There were 429 Liberty Jeeps stolen compared to 207,991 sold. for a rate of 2 per 100,000. True or false, and explain. The rate is low because the denominator is large. First off, note that this is a two-part question. You have a true-false and then an explanation. So the first thing to think about is the true-false. And what we need to examine here is this idea that the rate is low just because the denominator is large. Well, this has got to be false because in a rate, the denominator is always and only ever relative to the numerator. When you look at a rate, you compare rates, not raw numbers. We always need to remember this rule. If you're given some raw data or some raw, even a summary number of crimes in the US, for example, rates put raw numbers on the same scale by putting the numerator in terms of the denominator. So if you're told the number of crimes in 1991 versus 2001, you need to also say, hey, what's the denominator of the number of crimes? What was the total population at each of those points? That's putting the numerator in terms of the denominator. So remember, compare rates, not raw numbers. Thanks for watching this video. Be sure to check back in for more videos on the research design and descriptive statistics. Remember, for the most efficient way, do some statistics every day, and especially before you go to sleep.